as squared plus bs plus c. We are now asked to use the table to find the values of a, b, and c. Complete the table. Draw the graph of y, as squared plus bs plus c. Use the graph to solve as squared plus bs plus c equals. Use the graph to solve minus 2as squared plus bs minus c equal to 0. And finally, the slope of the curve. So let's start with the first. The best way to solve this is to choose 3 points from the, because we have 3 unknowns, so we need 3 points to form 3 equations that we now use to find the values of a, b, and c. And to choosing the points, since we are given 4 complete points. That's minus 3 comma minus 6, minus 2 comma 0, 0 comma 6, and 3 comma 0. But the first point that is if we choose, it makes our solution easy, is to choose this 0 comma 6, because remember, y-intercepts x is 0. So once x is 0, we can find the value of c. Do you get? So we choose the first point, which is 0 comma 6. So the first point we choose is at point 0 comma 6. That's the y-intercept. So we write at 0 comma 6, y, remember y is 6, x is 0. So x 0 squared plus b 0 plus c. So which implies that from this 6, 6, 0, 0, so 6, 6. So we've gotten the value of the first unknown. The second one is to now choose we now choose the other one, which is minus 2 comma 0. I told you the best point to choose is the intercepts, but I started with y because I started with y-intercept to get the value of c first, because assuming I started with the other one, I won't get the value of c. So the other one is minus 2 comma 0. That's the s-intercept. Remember, y is 0 and x is minus 2. Plus c. Remember, plus c, our c is 6. Have you seen why I started with y-intercept? So 0 here. This is 4a. This is minus 2b plus 6. So dividing both sides by 2, 2, 2. So 0, 2a minus b plus 3. So I divided each side by 2, which implies that 2a minus b equal to minus 3. So that's our equation 1. So I just moved plus 3 to the other side to be minus 3. So that's the first one. We now check the other one is 3 comma 0. So at 3 comma 0, so y is 0, x is 3. So which is b times 3 plus, remember, c is 6. So we have 9a plus 3b plus 6. Again, dividing both sides by 3 is 0, 3a plus b plus 2. I divided each by 3. Okay, which implies that 3a plus b equals minus 2. Equation 2. So we are solving equation 1, which is 2a minus b equal to minus 3 and 3a plus b equal to minus 2. We are solving it simultaneously. So adding equation 1 and 2, well, that's the only way I will eliminate one of the variable. So adding equation 1 and 2, we have equation 1 plus equation 2. We have 2a plus 3a is 5a, minus b plus b is 0, and minus 3 plus minus 2 is minus 5. Therefore, a is minus 1. Dividing both sides by 5 That's how we got A as minus 1. So the other one, to get B, we choose any of the equation and substitute the value of A. So let's choose equation 2. So from equation 2, we are looking for B now. From equation 2, B is minus 2 minus 3A, which is minus 2 minus 3 times minus 1, which is minus 2 plus 3, which is 1. So that's it. Our B is 1. Therefore, our function now, our quadratic function is y equals A is what? Minus 1. So minus x squared plus B, and B is 1 plus x and plus 6. So that's our quadratic function. Okay, the next thing is now to use the function, that is the equation here, to get the remaining values of y. The first value of unknown is when x is minus 1. So minus 1, 1 and 2. So let's find the corresponding values of y. So when x is minus 1, minus 1 squared plus minus 1 plus 6. This is minus 1 minus 2 and this is 4. So and when x is 1, y is 1 squared plus 1 plus 6. This is 6. And finally, when x is 2, y is minus 2 squared plus 2 plus 6. This is, it's 4. So that's it. So we'll fill up the table 4, 6, 4. 4, 6, 4. So we've gotten a complete table. So let's now go over to the graph. Let's plot graph of y equals ax squared plus bx plus c and use it to solve the quadratic equation. Okay, we are on the graph now. So see the graph book. So let's now plot these values. So we need to locate our x and y axes. So the first axis here, let me so that's my y. So these are y axis. So these are our x and y axis. So this first one is, so this is the origin. So remember from the table, okay, from this the maximum is 3 for x, while the minimum is minus 3. So let's locate the, but before then let's write this y axis, y this x axis. So let's locate this 1, 2, 3. Okay, if you remember, one of the box is 1 cm. So these 5 ticks, one. Okay, 1, 2, 3. Okay, this is minus 1, 1, 2, 3, minus 2, 1, 2, 3, minus 3. So let's locate for x, for y. The maximum is 6, while the minimum is minus 6. So, but here, if we count 1, 2, 3, it won't be enough. So why not this is 3, y this is. So down here we have minus 3 and minus 6. So but there's a problem here. We need to get each of these grid lines the value. So how do you get it? There's a simple way to do that. We just 3. That's we are moving 3 intervals. So 3 over what's the total grid line? We have a lot. We have 10 of them. So each of these grid line for y-axis is 0.3 or 3 over 10. So we have to do it this way because between minus 6 and 6 there is still 4 there. So we need to locate 4. That's why I calculated each of the grid line, and each of them is for y-axis is 3 over 10. Also for x-axis you can still calculate it 1 over 15. Each of them, because we move interval of 1, 1. Why the total grid line to each is 15. So each of them is 1 over 15. So let's now locate the point. The first one, when x is minus 3, y is minus 6. Okay. So this is the value. When x is minus 3, y is minus 6. So that's the point. So the second one, when x is minus 2, y is 0. So I think that's the point on the x-axis. Again, when x is minus 1, y is 4. So that is where we locate the 4 now. So let's now locate 4. So remember I told you each of the grid line for y-axis is 3 over 10. That's 0.3. So meaning that for me to locate 4, we now have to do 4 over 0.3. This should be 13.33 grid lines. Remember, I told you each of the grid line is 0.3. So for me to locate 4, I need to divide 4 by 0.3 so that I will not get the total. So if you check, okay, when x is minus 1, so I will count to 13 points. This is 5, 10, 11, 12, 13. So 13 should be here. 13 points something. So that's our 4. So the next one, when x is 0, y is 6. So that should be on the axis. So again, when x is 1, y is 6. When x is what? Y is 6. So this should be the point. So what? Again, when x is 2, y is 4. So the same thing here. Remember that we have to count 13. So 13.3. So this is 1, 2. So this is the point. So again, when x is 3, y is 0. So this should be the point. So let's now join our points. That's it. We are joining the points. So that's our point. Let's make it bolder. So that's our point. We've joined the curve. So we need to write the name. That's the function. So the next is to name the graph. The function, this is y equals minus x squared plus x plus 6. Okay, from this, remember I told you this is the solution of any quadratic equation by graphical method is the point of intersect. That's the point of intersection of x-axis and the curve. Remember the curve is minus x squared plus x plus 6. So from here our answer is, that's the solution. So the answer is minus 2 and 3. So coming to the fifth question, we are asked to solve this. But remember, we've gotten the value of A, B, and C. A is minus 1, B is 1, and C is 6. So we'll plug in the value. Minus 2 minus 1 x squared plus 1 minus 6 equal to 0. We'll have 2x squared plus x minus 6 equal. But remember, we're asked to use the graph, the curve to solve that. Remember, the curve is minus x squared plus. So we need to transform this to look like this. So the first thing, since the coefficient of x squared is minus 1, so I divide both sides by minus 2. So if I divide 2x squared by minus 2, I have minus x squared minus 1 over 2x and plus 3 equal to 0. So I've divided each by minus 2. So remember, our main aim is to get plus x, not minus half x. So I will introduce plus x and still counter it with minus 3 over 2x, because if you check, x minus 3 over 2x is minus 1 over 2x plus 6 minus 3. So looking at this, I've brought in plus x and plus 6. So the next thing is to move. So we're left with, let me write the curve we plotted. That's the curve. So move any other thing to the other side. We have 3 over 2x plus 3. So this is now the point of intersection. We have two functions here. That's the point of intersection. Point of intersection of y equals minus x squared plus x plus 6 and y equals 3 over 2x plus 3. So meaning whenever the two curves intersect is the answer. Remember, we plotted y equals minus x squared plus x plus 6, remaining y equals 3 over 2x plus 3. And the best way to plot this is using the intercept. So at x-intercepts, that is y is 0. So we have 0, 3 over 2x plus 3, which implies that solving for x, we have x is minus 2, y at y-intercept, that is x is 0, y equals 3 over 2, 0 plus 3. So solving for y here, y is 3. So these are the intercepts, the x and y intercepts. So let's now go over to the graph. Okay, so we'll now draw the line, which a line that passes through 3 and 2. A point that passes through 3 and minus 2 and cuts the axis. The line that passes through minus 2 and 3 and cuts the curve. So wherever it cuts the curve is the answer. So this is my line. So this is my line. So at the solution, is the point of intersection, which is minus 2, and let's trace out this. And So remember so if you could remember, each of these grid line is 1 over 15. If you check 5 times 15, so 15 over 1 over 15. So how many grid lines do we have to this point? 1, 5 times 15, 20, 21, so 22.5. So now each is 1 over 15. So 1 over 15 times 22.5 should be 1.5. So what we have here is 1 point. So what we have here is 1.5. So the answer is, our answer, remember this line y equals 3 over 2 x plus 3. So from this, we see that the point of intersection, therefore, the point of intersection of y equals minus x squared plus x plus 6 and y equals 3 over 2 x plus 3 is x equals minus 2 and x equals 1.5. So this is the answer. So why the final question? Okay, the final question, the slope of the curve at point x equals 1. So we'll go over to the graph. So looking at the graph, we have to find the slope at point x equals 1. So see x equals 1. So see the point. So remember, to find the slope is to draw a tangent line to that curve. So assuming I'll pick a line and draw the curve. I'll draw a tangent line, a line that touches the curve at only one point. Run the line. So let's now form a right angle triangle with the line. So is my change in x and so that's my change in x. Okay, let me use a thick line so that it will be visible. So this is my angle 90. So we need to get this point and this point and also this point. So remember, change in y over change in x. So let's get the points here. So at point A here, y, the value of y, remember each of the grid line for y is 3 over 10. So we have a total of 23. 5, 10, 15, 20, 1, 2, 3. So 23 times 3 over 10. So what we have here, 69 over 10, which is 6.9. Okay, let's just do it 69 over 10. This is 69. Okay, let me here, A for y. So remember, slope is change in y over change in x. So what we have here is 69 over 10 minus here, the value of y here. If you check this, 1, 5, 10, 15. So we have 15. So 15 times 1, 3 over 10 is 15 times 3 over 10 is 45 over 10. So we have 45 over 10 over for x value. So if you trace out down 1, 2, 3, 4. So we have, remember, each of the grid line is in x axis is 1 over 15. So 1 over 15 times 4, we have 4 over 15 minus y here is 1, 5, 10, 15, 20, 25, 30, 35, 40. So we have 40 over 15. Why I left it in fraction so that we can calculate fast. So we have 24 over 10 over minus 36. That's 6 over 15. So as you can see, this is minus 1. So the slope is minus 1. Yes, it's minus 1. So the slope of this curve at point x equals 1 is minus 1. So that's the answer. So whenever you have to draw it, you have to find the slope at a particular curve point. At a particular point, you just draw a tangent line to that point. Use the line to calculate the slope. So the slope of the line is equivalent to slope of the curve.